Good morning, all.
Very good morning, sir.
Is my voice is audible?
Yes, sir.
All of you.
Sir. No, sir. Little disturbance happened.
The disturbance. Yeah, now it is okay.
Yeah, it's okay, sir. Now.
Right. Now, in continuation to the previous topic, that is heterocyclic compounds. Previously, we have taken the definition. We are already understand what is the difference between the carbocyclic and the heterocyclic. Right. Now, I'm going to next topic, that is nomenclature. Classification of heterocyclic compounds. First, we are going through understand the classification. Later, we need to go for the nomenclature of heterocyclic, right? Then coming to classification of heterocyclic compounds. Classification of heterocyclic compounds. Yeah. Here we have several nomenclature, but no several classifications of heterocyclic compounds are there, but no classification will give the clear picture of different types of heterocyclic compounds whenever we are considering individually. But whenever we are combining all the classifications together, that will give the full-fledged classification of heterocyclic compounds. First, in the classification, the trivial names or trivial classification. classification. Trivial names are common heterocyclic compounds classification. It is the oldest classification. Here, the heterocyclic compounds are classified based on the heterocyclic compounds based on the source of compound. Source of the compound. For example, we consider the picoline, the heterocyclic. Picoline is the methyl substituted pyridine compound. This is a picoline. Now this is isolated from coal tar. This coal tar in the Latin word. The Latin it is called as pictus. P-S-C-A-T-U-S. Based on this source, that means picatus means tari. In the Latin, tari means coal tar. Right. Now this picoline source is coal tar. Based on that name, based on the source, it is named as picoline. In the IUPAC nomenclature also, the IUPAC nomenclature committee is also considered these names as official names. These names are official names. Till now, 60 trivial and semi-trivial names of the heterocyclic compounds are recognized by the IUPAC. 60, almost more or less 60 trivial names or semi-trivial. Names are considered or recognized by IUPAC. Some of the compounds, example, we consider the 5-membered nitrogen containing heterocyclic. Simply call it as in the IUPAC azole. Now its IUPAC name, Pirro. Sorry, its common name. It is the IUPAC name. Its common name or trivial name. TRC. T means trivial or C means common name. Right? Pirro. If you take oxygen heterocyclic with 5-membered, you studied in the UG level final year, right? This is furan. Thiopene. These are all trivial names. Thiopene. Pyrazoles. The 2 nitrogens are there. It is called pyrazoles. These are the 5-membered rings. When you coming to 6-membered rings, these are all 5-membered rings. Right. Next, coming to 6-membered ring, pyridine. pyridine, pyridazine. If the two nitrogens are there, if the number of if it is changed, the position of the nitrogen, two nitrogen, that is the 1,3 position there. It is called pyrimidine. These pyrimidines are commonly seen in the nucleic acids, the DNA, RNA. Next, if 1,4 position, pyrazine. Next, this is pyran. These are the 6-member rings. If you consider, these are the azine. When we are coming to the IUPAC, these are the common names. These are the IUPAC. You need to use the
Sir,
Yeah.
we have to learn it.
Right, we have to learn.
We have to learn these all names.
Yeah, by routinely you are using these names, automatically learn. No need to learn separately, right?
Okay, sir.
Azine. Azine is a simple nitrogen containing 6-member ring, that is azine. This is diazine. 1, 2. Diazine. It is 1,3 diazine. It is 1,4 diazine. Right. When you come into the oxygen containing 6-membered ring, oxine. That's it. Oxine. But we need to indicate the position of this unsaturated carbon. Two hydrogens are there. Are there when we are giving number 1, 2, 3, 4, 5, 6. That is 1, 2 dihydroxine is the name. Right? That is the difference between the common names and IUPAC. We have also several fused rings are also there. Fused rings with common names. Bicyclic or fused rings. Bicyclic. You consider these are all 6-member rings. Yeah. Next, coming to next one is bicyclic or fused rings. For example, this is nitrogen is indole. Isoindole. Nitrogen position. This is the position of nitrogen. Changing the this is isoindole. Right. Next, indazole. If the number of hydrogens are increasing, right? This is a 5-member ring combination with the 6-member. Next, if you take 2 are the heterosexual, suppose This is quinoline. Quinoline. This is the origin for this kind of molecules are first cinchona bar. Cinchona bar. Reason and based on that name, it is the source. Based on its name is given by the quinoline. Okay. In the Indian origin, we are cinchona, but in different origins, it is having different name. For that reason, it is called as quinoline. This is isoquinoline. Right. If you take the tricyclic systems, these are all bicyclic systems. Bicyclics. If you consider cyclics, carbazole, remember, are sandwiched between the two benin rings. This is carbazole. If it is not the five-member ring, if you are include the six-member ring with two nitrogens, two heteroatoms, like this. This is phenazine. This is phenazine. So many compounds are there. Next, if you coming to saturated, some of the saturated systems are also there. Heterocyclic compound. This is pyrrolidine, all saturated one. In the previous pyrrole, that is the unsaturated. It is the fully saturated pyrrolidine. Next, piperidine. Next, piperidine, morphodine. Based on the different heteroatom is present in it, you can call it as different names. Okay, these are all trivial names. All these trivial names are recognized by the IUPAC and also used in the regular protein chemistry, heterocyclic chemistry. Okay. Next, coming to classification based on the number of rings present in it, or ring size of the ring, or nature of the ring. Next, second type of classification based on the nature of ring. Type and nature of ring. The first type is small ring heterocyclic compound. Small ring heterocyclic index. 3 and 4 membered heterocyclic, 4 membered heterocyclic rings. Ring compound are called as small membered or small ring heterocyclic compound. heterocyclic compound. For example, you can take a 3-membered ring with one heteroatom, that is oxene. Oxygen, nitrogen heterocyclic with one nitro heteroatom. Azirine, name is azirine. If it is 4-membered ring with oxygen heterocyclic, the oxygen. Here it is having one pi bond. That is, whenever we are giving the number 1, 2, 3, 4. 2 dihydro oxygen. 2 dihydro oxygen. When you come into fully saturated, whether it are unsaturated, it is existing, if the ring is existing 3 atoms or 4 atoms are denoted as small ring heterocyclic compound. Now this its name is 1, 2, 3, 4 tetrahedro azitidine. Azitidine, Azitidine. Again, I'm writing it. It's not clear. Azitidine. Okay. This is the first type of heterocyclic compound in this class. Based on the type and nature of the ring. Yeah, tell me.
In the tetrahydro,
Yeah.
there is no
It is a fully
hydro
saturated
molecules.
one. Tetrahydro means here it is there, it is there, here. Right?
Okay.
Look at here, whenever we are comparing with, if you comparing with unsaturated, this is the unsaturated. So, it is a double one, here one double one. Okay? In this fully unsaturated one, here there is no hydrogen at the first position. Here one
Okay,
hydrogen is there, and here one hydrogen is there. Here another. Simply called it as azitidine. Azitidine. Whenever it is converting into fully saturated, how many hydrogens are excess and what are the positions? Here, in the previous case, here it is only one hydrogen, but here it is additional hydrogen is there. And the third position is also having additional hydrogen. 1, 2, 3, and 4. Whenever we are coming to first position, second position, third position, fourth position, or adding hydrogen, then it gets to fully saturated. Therefore, here it is having 4 hydrogens excess when we compare to its unsaturated one. This is the standard name. Azitidine is the standard name. The same name is using, but its saturation is indicated by this substitution 1, 2, 3, 4 tetrahydro. Whenever we are adding 1, 2, 3, 4 tetrahydro means the structure is fully saturated. Understand?
Okay, sir.
Your question
Okay,
is
sir.
clear.
Yes, sir.
Right. Next type B. Common heterocyclic rings. Common are 5, 6 membered 5, 6 membered heterocyclic rings. Heterocyclic system. Now, itself it indicates if the ring system may contain 5 atoms or 6 atoms. Then it comes under common ring system or 5, 6 membered heterocyclic ring system. This type of heterocyclic compounds. Generally, 5, 6 numbered rings of heterocyclic compounds. For example, you take pyridine, pyrrole, tran, thiopene, furan, thiopene, pyridine, tripyridine, okay, these are the examples for the cyclic systems, heterocyclic system. Next, third one, larger member.
సార్ డౌన్ చేయరా కొంచెం వాల్యూమ్.
Next, large ring members. Or we call it as large ring heterocyclic system. Compounds, system, whatever it is. Right. In this, generally, this type of heterocyclic compounds containing 7, 8, 9, and more number of atoms present for example in the ring are known as large ring heterocyclic compound. Large heterocyclic compound. For example, a 7-member ring, that is arginine, azipine, thiopene, right? I'm going to take you 7-member rings. This is the actual bond. Azipine, EP, just EP, oxipine, oxipine. Here the nomenclature last E may be listed. I've seen only. The 2 heteroatoms are there in the same 7-member ring. One is here, right? Another may be here, suppose. We called it as diazepines. diazepines. Everybody knows diazepines. Diazepines are used as tranquilizers, sedatives, right? Okay, these are the examples for the large membered rings. We can also take the 9-member ring, nonines, oxonines, okay, azonines. Like for example, I'm going to give you a 8-member ring. Yeah, we put here one oxygen, maybe 2 hydrogens are there here. Right. Now it is known as carbon dihydro oxygenine. Oxygenine. This is the 1 8-member. Okay. It is somewhat difficult to draw the 9-member ring and head. Right. 9-member ring and 10-member ring. I'll just try to write it. Just a minute. Yeah. You can write a 10-member ring just like this. Is 10-member ring. Just I'm considering here is this is a 9-member ring. Now, if you are using one nitrogen here, NH, right? This is 9-member ring. Its name is azonine. Azonine. If it is the 10-member ring, you can also draw the 10-member ring. Can use nitrogen here. Right. Those ethene, sorry, azoethene. Okay. Azo, this is the name. Azothene. Again, C is listed as ethene. Right. Azothene. This is the name. Right. I will discuss the nomenclature in detail whenever we are going to discuss the AUPAC nomenclature for the heterocyclic compound. Right. Next. Next type of heterocyclic compound, C. Condensed heterocyclic or fused heterocyclic. Fused or condensed heterocyclic compound. Fused or condensed heterocyclic compound. In that, that means 1 or 2 rings are fused together by the 2 carbons or 2 atoms. Two or more cyclic systems systems are fused or through two atoms to generate fused cyclic systems. For example, if you take two benzenes, two benzenes are fused through the two common carbons. These are the common carbons. Yes, fused cyclic system. Fused or condensed cyclic system. Heterocyclic systems are also fused together. For example, benzene. Just understand because I am showing like a equation. Are fused together by taking the common carbons, two common carbons. That leads to the formation of quinolines. Now these are known as fused heterocyclic. Fused or heterocyclic. Heterocyclic compounds. Right. This is the classification based on the arrangement of ring system in the manner of condensed or fused rings. We have several compounds are there. For example, indole, a heterocyclic system fused with the benzene. Then it is as indole, also known as benzo B pyrrole. Similarly, benzo B furan or benzoxazole, benzofuran, benzofuran. Benzofuran, benzothiophene, these are all the fused heterocyclic systems. Next, last type of the classification based on nature of heterocycle. Classification based on nature of heterocycle. Nature of heterocycle. Right. Here these compounds are classified heterocyclic compounds. Are classified into heteroparabenes, fully saturated heteroparabenes. That is fully satisfied valences. Heteroaromatics, this heteroaromatics again classified into simple heteroatom, simple ring heteroaromatic compounds. That is one heteroatom. For example, toluene is an aromatic and one heteroatom. That is called simple ring heteroatoms. Or you can take pyridine. This is also example for the simple ring heterocyclic compounds, aromatic cyclic compounds. And when you coming to next type, multiple heteroatom. Multiple heteroatoms containing heteroaromatic compounds. For example, here the nitrogens are there, for example. This is called diazoles, 1,2-diazole, right? Another example, just a minute. Here the one nitrogen is there. This is called thiazole. Thiazole, right? Next, fused heterocyclics. Fused hetero aromatic cyclic system. That is already we seen that. Indole, benzofuran, benzothiophene, quinoline, isoquinoline, quinoline, isoquinoline, indole. These are all comes under fused heterocyclic, heteroaromatic cyclic compound. Okay, these three classification, whenever we are considered individual or single manner, it will not satisfy the entire classification. Whenever we are combining all these classification together, then we can easily understand the classification of heterocyclic compounds. Right? Next, coming to nomenclature. This is about the classification. Three types of classifications are there. Based on the classification, we can understand the different kinds of heterocyclic compounds. Right. Next, nomenclature of heterocyclic compounds. For the nomenclature, we are always taken the IUPAC guidelines are the standards for the giving the name to heterocyclic compound. That is systematic nomenclature for monocyclic compounds. Why I am saying monocyclic compounds, I will tell you later, right? So, this heterocyclic compounds nomenclature is proposed by or introduced by the two scientists. One is Hans, and the second one is Widman. These two scientists are proposing the IUPAC name. Accordingly, first proposed by these two people. Later, it is improved by IUPAC. Right. What is the nomenclature? First, coming to what is the nomenclature. If any heterocyclic compound Any heterocyclic compound follows the following name structure. The first one is root R stem word and suffix. This is the structure of any heterocyclic compound name. The basic syntax, you can call it as simple syntax. That is the prefix, root word or stem word or suffix. What root word and suffix indicates or what prefix is indicated, right? Next. Right. First, you're coming to the prefix. What prefix plays role? This prefix indicates type of atom, type of atom present in it. Type of heteroatom present in it. For example, we are using the heterocyclic containing an oxygen with two valence. The valence is 2. Then the prefix is indicated with oxo or oxa. Sorry, simply oxa. The prefix should be oxa. That indicates that the type of heteroatom present in it. Suppose it is nitrogen. Suppose it is nitrogen. That is nitrogen with valence is 3. You can indicate the Roman. Yeah, 3. Now indicated with aza. Next, sulfur. It is sulfur with 2. The valence is 2 showing Thia. Oxygen oxa, nitrogen aza, and sulfur Thia. If it is other than these heteroatoms are also seen rarely, that is selenium. Selenium. The selenium is valence is also 2. Its root that suffix is prefix is selena. We are also using tellurium, Te. Okay. Here the valence is 2. Telina or tellura, sorry, tellura. Next, phosphorus. Phosphorus is also there. Phosphorus, the valence is 3. We are using phosphor. Arsenic. That is 3 valence. We are using silicon also. Silicon heterocyclic compounds are its valency. Silicon, like a carbon, it is Sila. It is Sila. Germanium, it is also showing the reason it is showing fourth valency. Germ, and last one. Three valence. Bora. Are the whenever we are using, suppose we have all the 5 members, 6 members, 7 member, 8 member heterocyclists are appearing with these heteroatoms. Whenever this heteroatom is appear, then always the name starts with this prefix. That is, if it is the tellurium, tellura, selenium, selena, phosphorus, phosphor, arsenic, arsa, silicon is the sila, germanium is the germa, boron is the bora. Like we are giving the names. First, the prefix is like this. Now coming to root words. Here, the root words, there is a specific root word or stem word. Here, the stem word or root word indicating stem or root. This is indicating the size of the ring. Size of the ring. We have different sizes are there, rings. If you 3-member ring, 4-member rings, 5-member rings, 6-member, 7, 8, 9, 10, 11 also. Okay, but I'm using here up to 10. Up to 10. I'm drawing a table, ring size. Please stop the annotation. Please. Those who are making annotation, please stop it. I'm making the table, ring size. If ring containing nitrogen heteroatom, that is having some different some name. Ring without nitrogen is also different. Ring containing nitrogen. If it is also again, if it is a unsaturated or saturated. Unsaturated, saturated. Again, the second type, ring without nitrogen. Without nitrogen. But other hard atoms. Here also that may exist in unsaturation. Or simply call it as unsaturated. Saturated. Please ask me if you have any doubts, because these basic concepts are very important. This heterocyclic topic will not end the first year. The entire heterocyclic or deepest heterocyclic topics are going to deal in the second year. Here it is only one unit. In the second year, it is 5 units block. One block, entire block will deal the heterocyclic compound. That is the reason these concepts, these basic theory is important to understand the heterocyclic compound, their properties and their preparations, their reactivities. Okay, all these are understanding whenever we are thorough with these concepts, the theoretical concepts. Even it is important to give the name for every heteroatom. For giving heteroatoms, you need to follow rules. These are the basic rules you need to follow whenever you are assigning the name for heterocyclic compound. That is the reason you need to concentrate on this topic, right? Here the ring size is a 3-membered ring. Ring size is 3-membered ring. We call it as, if it is the ring with nitrogen, if it is unsaturated means any 5 bonds are there. Saturated means the compound entirely with a single bond. The compound, if it is having one or more number of double bonds, that is called as unsaturated. Now, if it is the 3-membered ring means the 3 members. Only 3 elements are there. 3 atoms are there in the ring. That is the ring constructed with the 3 atoms. Now, any one of the carbon is replacing with X, hydrogen, sulfur, oxygen, or any other heteroatom. Now, if it is the saturated or unsaturated, suppose I am considering first unsaturated, one double bond is there, make it big, right? So X, where X is equal to nitrogen, sulfur, or oxygen. And this is the 3-membered ring. Now, if it is unsaturated, its stem word is irene. 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 If it is saturated, irene. If it is saturated, iridine. Suppose X is equal to nitrogen, you consider it as nitrogen. It is considered as nitrogen in the heteroatom. Nitrogen. Now, nitrogen containing ring system, it is unsaturated one. Then it is the prefix is nitrogen is there, therefore aza plus irene. Is that irene? Azarine. Now, the A is replaced with irene. Azarine is the name. The A is replaced with the irene. Azarine is the name. In this way, you need to give the IUPAC name, right? If it is unsaturated. Suppose the ring without nitrogen. Ring without nitrogen. That means here the ring system is constructed with any other heteroatom, like oxygen or sulfur, like that. Whenever, in this case, the name is irene. The root word is, or stem word is irene. If it is unsaturated, or it is irene. If it is saturated. Similarly, 4-membered ring. If it is saturated with nitrogen heterocyclic, nitrogen atom, it is saturated one, etidine, etidine. It is the oxygen heterocyclic, ethane. Yeah. Let me give example for everything here. I will take the, right. Suppose nitrogen heterocyclic is the unsaturated. The name is aziridine. Suppose it is fully saturated. Aziridine. Aziridine. If it is oxygen heterocyclic, suppose with unsaturation, oxyrene is fully saturated one. It's oxyrene. Right. In the case of 4-membered ring, if nitrogen is unsaturated, if 2 double bonds are there. Azete, if it is fully saturated. Azetidine, EIDIN. If it is oxygen heterocyclic 4-member, unsaturated. Now it is oxide. If it is fully saturated, oxetane. It is fully saturated. It is named as oxetane. Right. Now, next 5-membered ring. Right. 5-membered ring. For 5-membered ring, it is nitrogen with unsaturated O. For example, pyrrole. Right. It is the common name is pyrrole. Now, IUPAC name, Aza plus ol, azole. It is saturated one. Its name is olidine. Olidine. OLIDIN. Olidine. For example, you take the nitrogen with saturation. Azolidine. Right. Next. If it is without nitrogen, that is a heterocyclic compound, but nitrogen is absent, other heteroelements are present. The 5-membered ring furan. The common name of the compound is furan. Now, it is oxole. It is same with this nomenclature. Nitrogen containing heteroatom containing heterocyclic. And when you're coming to fully saturated, oxolane is oxolane. Next, it is 6-membered ring. Nitrogen heterocyclic with nitrogen and unsaturation. I. For example, unsaturated pyridine is a carbon, and I'm giving the IUPAC name is azine. Aza plus I. Aza, A is replaced with IN. Azine. If it is saturated with, that is, you take the piperine is the common. Piperine is the common name. Now, azanine. Azanine. Right. If it is the oxygen heterocyclic with unsaturation, right? What is the stem word? In, I-N-E, in. Oxine. If it is the saturated one, you take a fully saturated. It is named as oxane. Named as oxane. Right. Next, coming to 7-membered ring. 7-membered ring. If it is unsaturated with nitrogen heteroatom, epine. If it is saturated one, epane. No nitrogen, only oxygen or other heteroatoms other than nitrogen. epene and saturated epene. Epene. For example, nitrogen heterocyclic. Remember rings. Epene. Saturated. Right. Two hydrogens are there. No need to mention. Right. Now, azipane. The name is azipane. Suppose you take the same compound with oxygen. Every time oxygen, why you take sulfur now? Yeah, right. Dia plus Taiping is the name. Right. Saturated. Now you take the difference I am giving that saturated oxide. Right. Acipane. Right. This is a 7-member ring. Next, 8-member ring. 8-member ring. Its stem body is with high nitrogen heterocyclic and unsaturation is there. Phosphine. Name is phosphine. Phosphine. When nitrogen with unsaturation. Phosphine. Phosphine. OCIN. Phosphine. Again, oxygen other than nitrogen, other heteroatoms. Again, we can also call sometimes. Right. For example, nitrogen with 8-member ring. You keep any one place with nitrogen. Right. This is azosine. Azosine. Next, 8-member ring fully saturated. As hydrogen is there. If it is with any sulfur or oxygen, fully unsaturated. May not possible to take all the fully unsaturation. I'm starting from here. And here there is 2 hydrogen. Now we can also mention the substitutions of hydrogen, but it is here I'm giving the common in commonly. Oxocene. It is fully saturated. Oxocane. Oxocane. This is up to 8. Somewhat difficult in the case of 9-member and 10-member ring, but I'm giving the just names. If nitrogen with a 9, example, azonine, right? Onine, azoline, oxygen. Again, oxygen, onane, oxonane. The heterocyclic is oxygen heterocyclic, that is fully saturated, that is called oxonane with 9 membered atoms in the ring. The 5 is azoicyl, azoxyl, next to cycline, scale, size, oxycyl, oxycane. Here, all these are examples. Please consider. These are the examples. Okay, this is the way we are going to give the name for the compounds. This is about the prefix and stem word. Okay. Sometimes suffix may be appeared. Here the suffix is also there. Is there any end substitutions like carboxylate? If carboxylate is there, when we are using carboxylate, and if you have the aldehydes, carboxaldehyde. Okay, for the substitutions we are giving the suffix. For the substitutions, we are going to give the suffixes. Right now, here we have also have given the examples are also some rules are you need to follow whenever you are going to assigning the name, we need to follow some rules. What are that? State of hydrogen or saturations are indicated by the suffix or prefix by using the dihydro, tetrahydro words. For example, here in the previous case, I'm using pyrrole with fully saturated. Suppose it's fully saturated one. Whenever it is unsaturated, it is called as pyrrole. It is now what is called with the name. What is the 5-membered ring with saturated nitrogen? Right, what is that? Azolidine, right? Similar, its name is azolidine. But in the previous case, we are not indicating the number of saturated hydrogens. Here, the 4 saturated hydrogens are there. To indicate with the pre-prefix like or suffix, like azolidine, like that, or we can also for hydrogen azolidine, or we can also indicate the 1, 2, sorry, there is no 1, 2, 3, 4, 1, 2, 3, 4, yes, 1, 1, 2, 3, 4, 5, 2, 3, 5, tetrahedral azolate. In this way, you need to give. Now, this guideline follows like that. The state of hydrogens are indicated by most of the cases prefix is the suitable by suffix prefix. It's called pre-prefix. Pre-prefix. For example, two hydrogens are there, extra cyclic in the saturated carbon dihydro. If only one hydrogen is also there, we can also indicate that. One hydrogen, hydro, if the two dihydro, 3 tri 4 penta, like use same terminals. Especially these are compulsory. It is the fully saturated. In this case, no need to indicate the prefix like 4 hydro or 2, 3, 4, 5 tetrahydro azoline because it is completely saturated. These kind of indications are important or mandatory when it is partly saturated and partly unsaturated. So this case is there. Yes, whenever we are giving the number 1, 2, 3, 2 comes hydro, dihydro, pyrrole. Common name can also use or azole. Can also use azole. Like this, we are going to give the nomenclature or name. Next, second point is separating of the heteroatom or heterocyclic ring, numbering of the heterocyclic rings becomes essential when it is substituted. When it is or when substituents are present on the ring. Present on the ring. Next point. That means look at here. Same one. It is right. Like that. Suppose. Now 1, 2, 3, 4, 5. We need to give the numbering like this. This is the correct way. Whenever molecule are given numbering like this. It is wrong. Right? You need to remember like that. Now the numbering of the heterocyclic rings becomes essential when the substituents are present on the rings. Next. The heteroatoms is assigned and the substituents are continued. Substituents are counted around the ring such that substituent should get the smallest number. This is the rule you need to follow when you are getting the number. Heteroatom is assigned first number. And the substituents. Here, previous case, look at here. The previous case, I'm always starting the numbering with the 1 of the heteroatom. Okay. In this case also, in most of the cases, we are starting with the numbering with the heteroatom, right? Start the numbering with the heteroatom is the important. And my voice is audible?
Yes, sir.
Yes, okay. The heteroatom is assigned first number and the substituents are counted, substituents counted around the ring. Around the ring. In such a way that
Sir, voice is breaking.
Maybe your network issue. Here my network is okay. In such a way that substitution should get smallest number. Smallest. If the more than one substituents are present, suppose in some cases it is attached with more than one, 2 or 3 substitutions are there. In such case, you should follow the alphabetical. You need to assign the numbering in such a way that the first come alphabet gets the smallest numbering. First come alphabet will get the smallest. For example, CH3. Suppose ethyl group is there in this case. The numbering starts with 1, 2, 3, 4, 3, 5, L, azole. 3 methyl, 3 ethyl, 5 methyl azole. In this way, you need to give the assign the numbering. That means again, I'm repeating the same sentence. If more than one substituent is present, alphabetical order should be followed. Alphabetical order should be followed in such a way that the first come alphabet gets the minimum number during the numbering. Next one. In ring system, the position next to the heteroatom is assigned with alpha, beta, gamma symbol. Suppose here the 5 or 6 member ring is there. That is pyridine. These two positions labeling with the alpha symbol. Next position is labeled with the beta. The next position with the gamma. Whenever we are going to, suppose in the same pyridine, the methyl group is there. Now it is called pyridine. This type of nomenclature can also use it for giving the name. This type of labeling or symbols can also use it for the nomenclature. Next one. In some cases, heterocyclic contain more than one heteroatoms are there. Suppose more than one heteroatom. Same, if different or same heteroatoms may be present. For example, a 5-membered ring with oxygen and nitrogen is there. Or the 2 nitrogens may be there in such case. In some cases, 2 nitrogens are there. In some cases, sulfur may be also there. But whenever you are assigning the name, the order of priority should be followed. The heteroatom belongs to the higher group in the periodic table and has lower atomic number in that. When two or more heteroatoms are present in the ring, the prefixes di, tri, tetra is used when the same heteroatoms are present. The first case is, suppose in the heteroatom oxygen, sulfur, nitrogen, phosphorus, or silicon are there. Right? Always the prefix goes to oxygen first, sulfur, nitrogen. This is the priority. And next phosphorus and next silicon. For example, here the compound is there. For this compound, what is the name? In the priorities, oxa is the prefix. Oxa. And this is the azole. Oxazole. Oxazole. You can also indicate the numbering 1, 2. 1, 2 oxazole it is called. 1, 2 oxazole. 1 oxa, 3 azole. 3 sorry, 1 oxa, 2 second position is nitrogen. 1 oxa, 2 azole. That is 1, 2 oxazole. For example, if sulfur is there, it is the whenever you are starting with number 1, 2, 3, 4, 5. Here no oxygen. Next one is priority sulfur. Thiazole is the name is thiazole, and also indicate the number sulfur and nitrogen relation 1, 3 thiazole. 1, 3 thiazole. And suppose the similar kind of heteroatoms are present in the heterocyclic compound. Those two heteroatoms are there. Those two heteroatoms are same. Now it is called 1, 2 diazole. 1, 2 diazole. If the position may be changed, 1, 3 diazole. 1, 3 diazole. If the suppose 3-member ring, diazerine. Diazerine. If the 6-member ring, yes, diazine. Yeah. Okay, this is about the nomenclature. You can but you can take several molecules in our book and name them, practice them, right? If you have any doubts in the next week class, we will discuss. Okay, today I'm going to conclude. There is a time for the time is already over. Third class should be start. Now I am leaving. If you have any doubts, you can text me in the group. I will clear it. Right? Thank you.
Okay, sir. Thank you, sir.